Did you know Tableau Map Layer feature allows you to overlay multiple mark layers on a map? Well, that's true. Tableau released this awesome feature in version 2020.4, and Tableau recently came up with another mind-blowing feature where you can intersect the values in two or more layers. This intersect function was released in version 2022.4, and in this tutorial, I'm going to share how you can use multiple map layers with latest spatial functions in Tableau for spatial analysis. So without any further ado, let's jump straight into it. Welcome back, my name is Gurpreet, and if this is the very first time you are visiting this channel, then make sure you hit the subscribe button and the bell icon so that you can stay up to date with all of my videos. So let's get started. Multiple map layers are quite useful for spatial analysis. In today's tutorial, I'm going to show you a map of Sydney City Council and overlay it with multiple layers, and each layer will have different set of values. So as you can see here, I am showing the map of Sydney City Council, and I am showing different places, different layers for different values. The first layer is for using a buffer calculation, where I am showing Aboriginal places in Sydney City Council, and we can select these from this drop down. And currently I have selected Aborigines Welfare Board, and when I have selected it, it shows me the buffer calculation with the area of 1 kilometer radius, and we are showing this buffer calculation and showing that highlighted area from that particular point. And what I'm trying to show here is, like in that buffer area around 1 kilometer radius, I'm showing all the locations which have cameras installed and where are they installed on which street, and also all the parking locations within that 1 kilometer radius. So for this, I am using the data for Sydney City Council, which can be downloaded from this particular website, and I will be sharing the link of this website in the description below. So you can go here and pick up all the data sets from here. So if I want to pick it up for Sydney City Council, or even you can go and search here. So if I go to get data, and I can pick up, let's say, this particular data set from here. So here I just put, you can search the data set by just putting what you want. So if you want the data for all the trees in that area, you can search for that, and you can see tree donation data set, all the different species in the city of Sydney. And I have picked up same way the parking data. So if I search for parking, it will give me a list of all the parking options. So these are the parking meters, but that's a map which you can see here. You can also download the data as well here from this particular section. Parking permits area and parking meter status. So this is the one which I have used. And same way we can use it for the camera set as well. So I have downloaded all these data sets. So I simply click on this particular section. And once we click that, we will get the data set here, and we will simply download it from this particular website. So here you will go and simply click download, and it will give you different options how you want the data to be downloaded. So I downloaded the CSV version, and you can also see it on the map here, all the different locations of the parking data. So it gives you an idea how to use this data set, or how will it look like when you put it on the Tableau map. So that way you can pick up different data sets and create different combination or different layers on top of each other to get a really meaningful, insightful story from the dashboard. So let's create a new dashboard, and let's connect to the data set. So I have downloaded the CSV file, so I will use parking and safety camera and Aboriginal data set. So I have already selected all these ones. So I will open the parking meter data set first. And in that file, I can see here, we have all the data sets available here. So first one, instead of parking meter, I will remove that, and I will bring Aboriginal history places data set. And then I would like to create a relationship between multiple data sets here. So if we just bring this data set, and let's try to do the live connection here, and let's go here. And I want to bring x-axis and y-axis. And if you see here, the x-coordinate and y-coordinate are just a measure value. So that's why when I clicked on it, it gives me just a point, which is not right. I don't want it that way. I want it to be a latitude and longitude. So I will clear that section and I will go to this particular one and I will change the geographic rule and change it to longitude for x-axis and latitude for y-axis. And once I click on these two, you will see the map is created. But here it's just created 1 point. Again, I don't want it as a 1 point. This is because it's creating an average. I want to use it as a dimension. So if I change it to dimension, you will see all the different Aboriginal places are plotted on the map. Actually, in this case, it's using a parking meter data source. That's not right. Let's go back and check. So the name of the data set is parking meter, which we can change to city council. But the data set is Aboriginal historic places, and these are the x and y coordinates. And when we scroll to the right, you can see the name of different places, and we have few other information if we want to use as an address and everything else. So let's go back here and let's change the map to, let's say, normal street map. And once we do that, you will see all the streets are visible, and we can see when we hover over to these ones, we get the information on each of these points. So now let me bring name into filter shelf, and let's say I want to pick up welfare board as an example for the place. So when I click that, it will show me just 1 point, right? So this is here. Now I want to use this point to create a buffer calculation. So let's do that. So let's go here and create a calculated field and create a buffer calculation. So what is buffer calculation? Well, buffer calculation or buffer function is used to create a boundary around a spatial point. Or it's a way of measuring the distance between 2 points, right? So let's type in buffer. And when you hover over, click on that one, you will see on the right hand side, it gives you a bit of help on what the buffer calculation is and what syntax we need to use. So it returns a buffer of a given distance around a point, as I mentioned before. So what I need to do is I have to create a point, latitude and longitude locations, right? So here we can use Makepoint because we want to plot the point, right? So Makepoint function, we are going to use it to return the point on a map. So it returns a spatial object constructed from the latitude and longitude. So in this case, our y is the latitude. So I will use y, comma, x. And once we did that, so in the buffer calculation, we have used geometry. It's here. Then we need to use the number. So in this case, if we say we need 2 kilometers, or the radius should be 2, and then we need to define if we need to do in kilometers or in miles or different measure you want, or in feet or meters, you can use it that way. So here I will say 2 kilometers, right? And I will click OK. Now what I will do is, instead of plotting the chart this way, I will remove this and I will use my buffer calculation. And once I do that, you will see here, it will give us the buffer or a circle with a radius of 1 kilometer from that particular point. Now we can change the color. I want it to be less opaque, and we can do it that way. And I normally love to use dark map background, so I will change it to dark color. And here if you see, there are no streets or anything shown on the map. So I will go to map background layers, and on here we can select streets, and it will show us all the streets here. And you can select other options as well if you want to use area code labels or area code boundaries. You can use that one as well. And if you want to do water labels, it will show which water labels, like it shows Sydney Harbor here. If I remove that, it will remove those labels. So you can play around with these different values and it will help you to understand which one you want to use as per your requirement. So I will remove this as well. But if you click on neighborhoods, it will give you all the adjacent neighborhood points as well. So I will uncheck this as of now, and let's go back. So now we can see the location based on the selection of the name. So if I show filter and I want to change the name, you can see if I select multiple, it will show you multiple sections with the 1 kilometer radius. But in this case, I only want one. So I will, if you select everything, it will look something like this. So in this case, we will simply use Aboriginal Welfare Area. So now that we have created this one layer showing the Aboriginal places in Sydney City Council, now I want some more insights on this particular area. I want to understand how many parking meters are in this area and how many street cameras are on this area. So let's go back to the data source, and I would like to bring parking meters first and create a relationship with our data set. And in the relationship, we would like to create a Cartesian join because we don't have one-to-one mapping in these two data sets. If you don't have one-to-one mapping on these data sets, then you can use a Cartesian join by simply creating a relationship calculation and writing in 1 here. And the same way on the other side, we will create calculation with the 1. So once we do that, it will create a Cartesian join between these two tables. So once we create the relationship between these two tables, let's go back to the sheet and let's plot all the parking meters on this particular map. So we need to create another layer. But before we do that, you can see here these two tables are created automatically. And we have X and Y coordinate here as well. But these are again in the form of measure values as a number. So first of all, we need to create the geographical rule and change it to latitude and longitudes. So once we do that, we will have latitude and longitude created. So now, as I created make point in the previous section in the buffer calculation, I will create another calculated field for make point. So let's type in make point. And make point, it is a function used to convert latitude and longitude columns into spatial object. So when we type in make point here, you can see the help section on the right hand side, which will tell you the syntax, what to use and what not to use. So here I will put Y for the parking meters and X as a latitude for parking meters as well. So once that is created, we can simply bring the make point and drag it onto the map and add it as a mark layer. And once we do that, this section is created here, and you can see here nothing happened actually, right? You can only see one particular point here because it averaged all the points for that particular parkings into one particular location. But we don't want it that way. We want all the meters to be shown on the map. So we can bring the meter ID and we can bring into detail shelf, and you can see all the meters are now shown here. So now the challenge is I don't want all the meters which are outside that area. I want to see all the meters, parking meters within that 1 kilometer range. So how we can do that? So that's where the recently new feature introduced by Tableau is Intersect function, which is quite powerful and quite useful in such scenarios. So we will create an intersect function here. We will create a calculated field, and intersect function allows us to determine if the two spatial objects overlap. So in this case, the buffer calculation and the parking meter locations are overlapping. So we will use this intersect function to return the Boolean value, which is true or false, and tells us which all points or the areas is intersecting, and we can show that on the map. So it asks us to create a geometry 1 and geometry 2. So we will say buffer calculation which we created, we want to intersect everything in this buffer calculation, and then we will use make point which we created for all our parking meters. And the valid calculation, it's a valid calculation, we will click OK. So once we click OK, we will bring this intersect calculation into the filter shelf. And in the filter shelf, it will give us two values. One is true and the second one is false. And in this case, we will select true value and select OK. And here you go. You can see all the parking meters within that buffer calculation for that particular Aboriginal area. So that's pretty powerful, isn't it? And you can now change it into shape as well. So I don't want to see the circles. So I will simply go and change this section to a particular shape. And I will change the shape here, go to more shapes, and I will change to custom. And I don't have the icon there, so I have the icon in the parking section, and I will use this icon and press OK. So you might be wondering how I have these icons here, right, in these shape selection. So I have downloaded these different shapes and saved it into Tableau repository. So when you install Tableau, you will go to Documents, and under My Tableau repository, there will be shapes. And you come here, you can create a new folder, or you can just use the existing folder and add whatever shapes you like here. So that way you can add different shapes. And now I want to add another layer. For all the cameras, I want to see which all areas have different cameras and where are they located. But before that, I want to add more information on these parking meters. We just have parking meter ID because we have added meter ID in the detail shelf. So now I want to add a street and suburb in the tooltip as well. And I want to see if credit card payment is allowed in that particular parking meter. So I have added all of these information in the tooltips, and when I hover over to any of these ones, it will tell us the meter ID, the street where it is located, the suburb where is it located, and also if they accept credit card payment or not. So that way you can add as much information you want on particular location points. Now let's bring another data set, which is street safety cameras. So let's bring it here and let's create another relationship. And as I mentioned earlier, there is no one-to-one mapping in these data sets. But if you have one-to-one mapping, you can use those fields to create one-to-one mapping. But in this case, I don't have one-to-one mapping, so I will use Cartesian join here as well. But one thing you guys have to remember with the Cartesian join, the data set is really big, gets really big, because it's many-to-many relationship, right? So that's why we have to be really mindful when we are using these data sets. If you have really big data sets, really big tables, then you need to find one-to-one mapping and try to avoid using Cartesian join because it will increase the data set and it might impact the performance. So now in this case, I have created another data set. I have brought another data set and joined it with the historical places data set and created the relationship. So now let's go back to the sheet 1, and we will see here the street safety cameras data set is there. Now, same thing, we have to change the geographic rule for these X and Y coordinates, and which I will do quickly. And once we do that, I will again create a make point calculation, but this one is for cameras. And once I do that, so I will be using Y coordinate for latitude, and I will use street safety cameras, and then X coordinate for street safety cameras. And now I will bring the same make point calculation and create a new layer in there. Once I do that, you will see all the camera locations are plotted on the map in blue circles. So I would like to change the shape as well, and I would not like any of the camera locations which are outside the circle to be displayed. So we can use another intersect function. But before that, let's change the shape of these camera location to actual shape, right? So I will go to shape, and you will see here, once I do that, you will only see one point. This is because it's aggregating and giving me only 1 point after doing the aggregation to average. So I will bring all the camera unique IDs, so in this case camera number, into detail shelf. And once I do that, you will see all of them are plotted separately. And instead of sum of camera number, I will change it to dimension. And you will see instead of one circle, you will see all the cameras will be appearing in this buffer area. And here you go. And now we will go to shapes and select the camera as a shape. And I will simply go to more shapes and change it into custom, where I have saved the camera icon, and press OK, and you will see all the camera icons are there, including the one outside that buffer area. So now we already have one intersect for parking meters and Aboriginal historic places. Now we need to create another intersect function for safety cameras and Aboriginal places. So how we will do that? Create a calculated field and intersect underscore cameras. So I will create another field and then I will use intersect function and use buffer function here and make point function for cameras here, and it will give me a boolean value, so which is true or false, and I will bring this and put it under the filter shell, and you will see once I select true, all these cameras will disappear and it will only show me the cameras which are located in that particular area. So after that it will look something similar to this, where we have all the cameras and parking locations within the buffer area, and we can actually add any sort of information on top of these camera locations. So we have added camera locations here by bringing the dimension of locations into the tooltips. We can also add precinct by bringing that into tooltips, and when you hover over to this camera you will see all of these information displayed on the map. And you can see here camera number is 203, location is George Street, precinct is Circular Quay. And once we have this enabled, we can make it more dynamic in terms of this buffer area. So instead of right now we have selected 2 kilometers. If we want to change the buffer calculation to just include 1 kilometer, we will go here and change that to 1. And you will see here the buffer chart, the area will reduce to only 1 kilometer. And here it goes. It will look something like this. And if we want to make it dynamic, we can create a parameter for integer value, and we can say or give it a name as radius, and we will change it to integer value, and we would like to have it a range. So we can do minimum 1, maximum as 5 kilometers, and step size of 1 kilometer, and we press OK. And we will go to buffer calculation, and instead of giving the value here, we will ask it to select the value from radius, and we will show this as a parameter, and you will see it is 1. And if we change it to 2, it will increase the radius to 2 kilometers, and it will look something like this. So that's how we can use multiple map layers with different spatial functions, and especially the latest one is intersect function, where you can overlay multiple values from different layers and only show the values which are intersecting between the two layers. I hope you guys enjoyed this session. If you have any questions, please feel free to drop a message in the comment section below. And I will put all the links in the description below. Thank you.